tree traversal. Okay, so the topic is I have a tree and I'd like to visit every node. And let's see, where is this? Does it say in my notes? Search, is there a search? Yes, there is. Yay. Okay. So let's say we have a tree. It's a capital T tree. It's an abstract tree. And we have, I don't know, losing my mind. Oh, Roger, that's right. And Ray, and Dave, and Pete, and Nick. Okay? Whatever, it's a tree. My job is to go through this tree, printing out the datum of every node, one per line. Okay? Well, there are two basic ways I can do that. They're called depth first and breadth first. Depth first says, okay, I've printed out the word music. Now what I'm going to do is look at the first child. So far we could be in either breadth or depth first. And when looking at the first child, it's a tree, and I'm going to look at the whole thing. So the datum at this child, I'm going to print Beatles, then I'm going to print John and Paul and George and Ringo. And then when I'm complete, and if some of these had grandchildren, I would print them too. Then when I'm totally finished with this tree, then I move on to the next sibling. So it goes down before it goes sideways. That's why it's called depth first, tree traversal. Okay? The program to do it is very simple. It's the first three lines at the top of the screen. So to depth first search a tree, and here all I'm going to do is print out the datum of each node. So I start by saying, print the datum of this node, music. And now I'm going to say, for each of the children, depth first search them. So I'm going to depth first search Beatles, which means I'm going to print Beatles, I'm going to print John, Paul, George, Ringo. Then I'm going to depth first search Who. And I'm going to print Who, Pete, John, Keith, I forgot again, Roger, thank you. I am so getting old. And then after I finish that tree completely, I'm going to go into kinks, and I'm going to do Ray, Dave, Pete, Mick. Okay? That's it. That's very simple. And the reason it's so simple is that my processing of the tree is following the actual links. Okay? Because there aren't any links from sibling to sibling in a tree. The linkage is all child to parent, parent to child. So in order to get from Beatles to Who, I have to sort of think sideways. Right? Whereas in depth first search, remember each child, here's the real point, each child of a tree is a tree. So if I do a recursive call for the child, it's going to do that whole tree. So for each, calls depth first search for each of the children. And that's the pattern that I get.